Hi, today I'm going to talk about Chinese remainder theorem. According to Wikipedia, it states that if one knows the remainders of the division of an integer n by several integers, then one can uniquely determine the remainder of the division of n by the product of these integers, provided certain conditions are true, namely provided the divisors are pairwise co-prime. So let's see what that means in an example. I will be looking at this particular site here, and this particular example. So let's see here what it says. X equivalent to 1 mod 3, x equivalent to 2 mod 4, and 3 mod 5. So what that means is, there is a number here which leaves a remainder of 1 mod 3, remainder of 2 mod 4, etc. So the question is there a solution to this problem? Is there a number which exists which satisfies all these criteria? So according to Chinese remainder theorem, as long as these modulus numbers, the 3 4 5, as long as they are pairwise co-prime, meaning any combination of these two are co-prime, then there is one unique solution, and that solution would be in mod product of these numbers, which would be 3 times 4 times 5, which is 60. So our solution here should be less than 60. It could be anywhere between 0 to 59. So we will try to solve this using Excel, and we'll see how we can do that using Excel. So for the first one, the first positive number would be 4, and anything after that would be 3 more, 3 more than the previous one. So all these numbers here, they are equivalent to 1 mod 3. So the last number here is 61. So our solution space actually is limited to this because it's mod 60. So our number is going to be less than that. So from here, what we will do now, we will try to see which numbers out of this leave a remainder of 2 mod 4. So we will use this if mod of a3 mod 4 of a3 is equal to 2, then print a3, otherwise print 0. Control C, Control V. So these numbers here we get, some of them are mod 2, some of them are equivalent to 2 mod 4. So we can do the same, and Control C here, Control V, and this time it's going to be a4, mod would be mod 5, and we are looking at 3. So that's our solution right there, which matches with this website. So 58 is one solution, which is one unique solution, mod 60. But if you look at other congruent numbers mod 60, I have just listed them down here. So these are also all the solutions, but they are same as they eventually are same as 58, but they are also congruent. So now I will try to make sense out of this Gauss's algorithm here, which we can use to programmatically determine n. So earlier what we did was manual work, but it's not going to be feasible if the numbers are large. So we have to find a way. So for that we can use Gauss's algorithm, and I'm going to see if we can work this out. So what it does, it says this number n, it does this calculations, and so we'll try to do this by hand and see if that makes sense. So we will use this, and I will simplify this here. So x equivalent to, I will just say 1 dot a dot is the product, and in this case one these values, c values here in this equation here, c1 c2 cn, these are in our example these are 1 2 and 3. So I will just say this c x equivalent to 1 times a plus 2 times b plus 3 times c. So basically we are dividing this number in 3 parts, and we will try to come up with a bigger number which will be reduced to, which should be reduced to 58 mod 60. So if we can write like this, then let's consider this first equation alone. So if this whole number is going to be 1 mod 3, then these two terms should be completely divisible by 3. So we can write like this. So this is equivalent to 2 times 3 times b plus 3 times c. So if we follow the same procedure for other two numbers, so let's do it for the second one. Then did I copy this, copy that? So this is same as 1.4 and 3.4.4.c. and if we consider the third one, then we multiply third one 1.5 dot a. So our x will be something along these lines, so which is same as so we reduce this to 20, this is 15, and this is 12. So which kind of matches here. So 1 times 20 with this equation here, 1 times 20 times 2, so we don't know the 2 yet, so 2 times 15 and 3 times 12. So what is this a? How do we determine this? So basically if we go back to the same thing we said earlier, looking at just this first equation here, if this equation were to hold true for 1 mod 3, then these two numbers are already 0 because they are already factors of 3. And if this were to be 1, then 20 times a should be 1. So that's what we are doing here. So a, basically we need to find a, so that when we multiply a by 20 mod 3, then we get 1. So in other words, we are trying to find the mod inverse of 20 in mod 3, and similarly here mod 4 and mod 5, and that is what this equation here is doing. So in mod 3, mod 4, mod 5, this is the mod inverse of 20, 15 and 12 respectively. So a in this case becomes 2, because if we multiply 2 by 20, which would be 40, and that would be 13 times 3, 39, that leaves a remainder of 1. So similarly this will have a remainder of 1. This will basically be 1 reduced to 1, and that's how we come up with this solution here, 238, which is reduced to 58, which is same as our original number. Okay, so there is a lot more to Chinese remainder theorem than what I have covered here, but I hope this will get you started, and I hope you learned something out of this.